Hi guys, welcome back to my channel. For this day, for this video, we're going to have a chapter summary in chapter 4, which is entitled Network Access. This is to support our communication. The OSI model divides the functions of the data network into layers. Each layer works with the layers above and below to transmit data. Two layers of the OSI model are so close tied that according to the TCP IP model, they are in an essence one layer. Those two layers are the data link layer and the physical layer. On the second, on the sending device, it is the role of the data link layer to prepare data for transmission and control how that data accesses the physical media. However, the physical layer controls how the data is transmitted onto the physical media by encoding the binary digits that represents data into signals. On the receiving end, the physical layer receives signals across the connecting media. After decoding the signal back into data, the physical layer passes the frame to the data link layer for acceptance and processing. This chapter begins with the general functions of the physical layer and the standards and protocols that manage the transmission of data across local media. It also introduces the functions of the data link layer and the protocols associated with it. So, in this chapter, we study about the managing of a medium. And we have here the types of connections. The home router has embedded wireless antenna, internet connection, and Ethernet switch. Network interface cards. Network interface card connect a device network. Not all physical connections are equal in terms of the performance level when connecting to a network. All wireless devices must share access to the airwaves connecting to the wireless access point. This means slower network performance may occur as more wireless devices access the network simultaneously. A wired device does not need to share its access to the network with other devices. Each wired device has a separate communications channel over its Ethernet cable. This is important when considering some applications such as online gaming, streaming video, and video conferencing, which require more dedicated bandwidth than other applications. And also, in these topics, we will learn about the physical layer connections that occur and how those connections affect the transporting of data. We also study here the physical layer and the process that data undergoes from a source node to a destination node is the user data is segmented by the transport layer, placed into packets by the network layer, and further encapsulated into frames by the data link layer. The physical layer encodes the frames and creates the electrical, optical, or radio wave signals that represent the bits in each frame. These signals are then sent on the media one at a time. In the physical layer media, there copper cable, fiber optic cable, and wireless. The copper cable is the signals are patterns of electrical pulses. Fiber optic cable, the signals are pattern of light. Wireless, the signals are pattern of microwave transmissions. The figure displays signaling examples for copper, fiber optic, and wireless. Also, we study about the characteristics of copper cabling. We can see that there is a pure digital signal, the interference signal, the digital signal with interference, and what the computer reads. Data is transmitted in a copper cable as electrical pulses. A detector in the network interface of a destination device must receive a signal that can be successfully decoded to match the signal sent. However, the longer the signal travels, the more it deteriorates. This is referred to a signal attenuation. For this reason, all copper media must follow strict distance limitations as specified by the guiding standards. Also, we study about the unshielded twisted pair cable. In the unshielded twisted pair cable, there is a outer jacket which is in the outside, and in the inside there is a twisted pair and color-coded plastic insulation. The outer jacket protects the copper wire from physical damage, while the twisted pair protects the signal from interference. Then, colored coded plastic insulation electrical isolates wire from each other and identifies each pair. We also have jacket, braided or full shields, and twisted pairs. Also, we study about the data link layer. The data link layer prepares network data for the physical network. The data link layer effectively separates the media transitions that occur as the packet is forwarded from the communication processes of the higher layers. The data link layer receives packets from the directs packets to an upper layer protocol. In this case, IPv4 or IPv6, this upper layer protocol does not need to be aware of which media that communication will use. Also, we study about the controlling access to the media. The topology, how the connection between the nodes appears to the data link layer, and the media sharing, how the nodes share the media. The media sharing can be point to point, such as in WAN connections, or shared such as in LAN networks. So, in overall, this chapter began with a look at the TCP or IP protocol suite. This included a look at the protocols that make up TCP or IP at the way in which they relate to the iOS, ISO or SSI model. A look at network layer protocols to provide an overview of IP packets and addressing the way in which are in use to map IP addresses to MAC addresses, as well as how ICMP provides error reporting and diagnostic information. Examination of protocols at the transport layer provide an overview of the both TCP. So, yun guys, we are done in the summary of chapter 2 and I hope that you understand. So, thank you for watching. Please don't forget to subscribe and click the notification bell so that you will be updated on my other videos that will be uploaded. Bye guys!